Our next station is solving or evaluating. And so this goes back to how we solve equations that are exponential equations. And the best way I could show you how to solve exponential equations is to go back to our notes that we had on those exponential equations. So the first thing we had was 16 to the v equals 67. And what we started out by doing is saying, okay, we're going to take the log of both sides. So we took the log of 16 to the v, and that equaled the log of 67 because we did the log of both sides. Then we used our properties of logarithms that said that that v can go in front. So that property of logarithm said that v times the log of 16 equals the log of 67. And then in order to find what our log is, or what v is, we basically divided both sides by the log of 16. So we divided both sides by the log of 16 here. And here. And then we found out that the log of 16, the log of 67 divided by the log of 16 was our answer. And we just typed that in our calculator, making sure to close the parentheses on the 67. So we had the log 67, close the parentheses, divided by the log of 16. And I got 1.5165. 1.517. Okay, same thing happened over here. The only difference is we first divided both sides by 4 so that we could get it so that the base was by itself. So we did 30 divided by 4 and we got 7.5 equaled 1.2 to the x. And then we did the log of both sides. We had the log of 7.5 equals the log of 1.2 to the x. And then since we knew our properties, we had the log, I keep hitting that and it doesn't change, of 7.5 equaled x times the log of 1.2. And then again, we divided both sides by 1.2. So that's what you want to do when you're solving these properties here. Okay? And then we just type that in our calculator. Making sure to close the parentheses on the 7.5. And we got 11.0513, so 11.051, bam. Okay? Now, the other thing you might have to do is the change of base theorem. Remember I told you this really didn't matter? Because when we see the log base b of x, we could write that as b to the y equals x and solve. So if you see a problem that's the log base 2, log base 2 of 7/9, or of 7, and you want to know what that is, well, basically what you could do is you could do the log of 7 divided by the log of 2. And that's using your change of base theorem, or you could use the fact that the log base 7, the log base 2 of 7 means that 2 to some power has to equal 7. So when we take the log of both sides, so our x comes in front, and we end up dividing by the log of 2 anyway. So you could solve it either way. Okay? So that's just a little something to remember as you're looking at these problems on this particular page. So to actually calculate what that is, we've got the log 7, close the parentheses on the 7, divided by the log 2. Not as important to close parentheses, but still it matters. And we end up equaling 2.807. So that's to the nearest thousandth. And if they wanted to the nearest hundredth, it would be 2.81. Okay?